I'm Paul Massey from Bluefruit Software. I'm founder director. My background is in embedded software, agile and medical devices. Bluefruit Software are embedded software specialists. We've been around 25 years and just celebrated our 25th birthday. We've got about 60, 70 people. We're based over in England, in the UK. And we get involved in all kinds of sectors: medical, functional safety, aerospace, defence. And we are agile through and through in what we do, which is going to come through probably in my talk today. So I'm going to do some polls as we go through. So if you can kind of connect with your mobile phone to this app, either go to that URL or just point to that QR code. And let's just have a go at getting that working. So first poll here, see if the technology works. Let's just see who we've got here tonight. If you can't lock onto that VR code, you can go to that URL. There we go. So first question, which of these best describes your job? Amazingly, the technology is working, which is good. Looks like we've got a good mix of some leadership and some techies here and some others. I obviously didn't have enough categories. I know I've chatted to some people, so yeah, a few other roles here today as well. Great. It says 16 out of 14 people have responded. That's good, isn't it? Yeah. Okay, and then just one more poll before we get started. So that's the results of that one. Just to help me get a sort of feel for the audience today and what technologies you're kind of familiar with. If you could just complete that little quiz around what familiarity you have with AI coding tools, agile, BDD, and mutation testing. Okay, so now I'll get stuck in. So I'm going to be talking about AI coding, using AI tools, and how maybe we can do it a bit more safely and use those tools a bit more safely, because I think most of us have had to play with those. They seem to help quite a lot. They seem to generate lots of code, but how can we actually make that useful in our day-to-day jobs? So I'm just going to start with something called vibe coding. In case you don't know what this is, basically, as a user, you can just put in a plain text prompt into a vibe coding tool, and as if by magic, it transforms that into some executable code. So there's an example here that I was just trying out. I'm using a tool called bolt.new. I quite like bolt.new because not only does it generate all the code for you, but it also deploys it onto a website. It sets up the database backend. So what I'm putting in here, you probably can't read it, is build a dosage calculator for ibuprofen, asking the patient's age to establish if they're a child or an adult, enter their weight and symptoms, and automatically calculate a suitable dose and provide appropriate warnings. This video is on 4x speed. Down here you can see how long it's been running, about 2 minutes there. But basically you enter that prompt, it generates all the code, deploys it to the server. Bolt.new is great because it's got like GitHub integration and things, so you can get into the code and start evolving that. But it's very much a vibe coding tool. So what that means is you can get somewhere very quickly. So here, after just 3 minutes after entering that prompt, it's generated a full website. You can enter age, weight, enter your symptoms, submit that, and it's now calculated recommended dose, frequency, and has given us all the kind of appropriate warnings. So amazing productivity, and it's got some really good uses and really good pros, but also some cons that we need to be aware of. So first up, pros. It's highly productive. As you see, in 3 minutes, we've created something that you might have spent 2 or 3 days doing. It's really creative. So what that means is we can create 3, 4, 5 prototypes very quickly and put those in front of users and get all kinds of ideas about what our tool might look like. And by having those wide range of solutions and producing lots of solutions very quickly, we can get surprising solutions from that as well. It's great for prototyping. So if you use something like Figma for your workflow, this is a great alternative, or maybe something to run alongside that. So instead of producing a kind of clickable prototype, we can actually create some working software that we can put in front of users and gather feedback very, very quickly. So these are all massive advantages of vibe coding, but there are some drawbacks, some quite serious ones. So there's a lack of transparency. So we don't really know what it's doing. It's doing designs without really consulting with us. There's no traceability. So normally when we write some software, we have some requirements and those trace through to specifications and the code and the tests, and we try to link all that together. Here it's just gone ahead and made a load of decisions. And then probably for me the most important one here is unsafe assumptions. So as engineers, all day, every day, we're making decisions. And they might be small technical decisions, drawing on our experience. They might be high-level decisions that we're consulting with users or stakeholders on. And that's part of engineering, is making decisions and making good decisions. That's what we're kind of paid to do, and we draw on our experience to do that. The AI has made tons and tons of decisions without referring to anyone, without checking in, without checking whether they're the right assumptions. And so this is a problem. The code that's produced here also isn't compliant. In this case, medically compliant, but if we're in a different space, a different domain, it wouldn't be following any of the relevant standards. And in this case, in terms of medical, maybe you wouldn't trust your life with what it produced either. As somebody who's spent the past 25 years developing teams, helping junior developers build their skills, actually these cons are quite familiar to me. These same issues are the same issues that I see with human developers. These are the same mistakes that junior developers or even more experienced developers might fall into. So that kind of set me thinking that maybe some of our toolkit that we use to help keep junior developers on track, maybe they'd be useful here. So before I dive into that though, let's do another poll. How the audience tonight feel about trusting your life with the app that's just come out of that vibe coding? Would you be happy with making a dosage calculation based on what was seen there, or even more, using it to provide a dosage for your child? Okay, quite a range. I did this presentation a couple of days ago at the conference, and there was less of a range. I don't know if the open bar is making people a bit more confident in the. But we're seeing about an average of 3 there, which is not great. So let's just lock that one down. So what tools have we got to help us manage developers with these challenges? Well, first up, we have standards. Depending on what domain you're in, we have standards like 61508 for functional safety, 62304 for medical, which will be relevant here, or 82304, maybe more relevant here. DO178 for aerospace. Plenty of standards, plenty of numbers out there. What do these do? What are these for? How do they help us? Well, the key element of any of these standards, most of these standards, is first up, they give us traceability of decisions. As I briefly mentioned already, we may have product requirements, user needs, and these trace down through our software requirements. through to the design, down to the detailed design and the source code. And then we have the standards tend to give us recommendations on how we verify against those steps in our V model. And we can verify that our solution actually complies with the detailed design that we've outlined, the specifications that we've agreed and reviewed with stakeholders and we've approved. And then we validate against those user needs to make sure it actually does what the user needs. The standards also talk about risk management, and they also guide us through making sure that all of this is auditable, so we can actually prove that we've done these things as well. So in my experience, standards are really useful. They give us a framework, but alone they're not enough. They do prevent the chaos, but they can also slow down innovation, and innovation itself can be an important part of making sure that you have high quality software and safe software. Also, I've often seen standards can lead to a kind of tick box mentality. So this is where teams are kind of following processes, following practices, but they're not necessarily delivering the intended quality. So for example, with unit testing, I've seen teams do lots of unit testing after the software's been written, and that doesn't necessarily mean that those unit tests are particularly effective. So to counter this, something we do at Bluefruit is we use agile practices. And what we find is agile practices bring some balance to the picture. So they strike a balance between safety and actually speed, which gives us innovation. But they also ensure that the quality is actually built into these practices. So for example, test-driven development is a great way of developing unit tests in a way where they're actually effective and add value to the project. So we've got standards and we've got agile practices. Let's just talk a bit more about what agile means. I recruited Google VO here to generate a video to help convey what agile means. This video is trying to convey iterative development, so we can see this product evolving through from being a skateboard through to something more useful. So agile means we can do rapid prototyping with short feedback cycles and get feedback from users and stakeholders, whether we're actually developing the right thing that's going to meet the user needs. That might sound like a scary approach if you're not familiar with Agile. It sounds like most people here were familiar with Agile. But there's some great work being done in medical, for example. There's a document called TIR45, which talks about how we can use Agile practices to deliver the standards and the expectations in the standards. Agile is made up of a toolkit with dozens of tools in it. To mention just a few, there's one called Behaviour-Driven Development, which I'm going to be talking about a bit more tonight, which gives us a way of collaborating between the product team, stakeholders, developers, testers, and generating useful specifications. Test-driven development, I mentioned a little bit, which helps us test our software more rigorously at the unit level. Continuous frequent integration, the list goes on. So Agile gives us this toolkit. Today I'm going to zoom in on behaviour-driven development in particular. So at the heart of BDD, behaviour-driven development, is what's called an executable requirements model. So what this does is it allows us to build specifications in the plain text English that you may or may not be able to see there on the left-hand side. It's in plain English given when then, so given a context, when an event occurs, then we get an outcome. So we write these in plain text English, but the toolchain then allows us to automate those specifications. They're actually, one of the clever tricks of BDD is we bring together the specifications and tests into one artifact. So having brought those together, we can then automate those lines, and we can see here that we can then run those specs and demonstrate whether the current target software is aligned with what those specs say. So here we can see that some of the lines pass, some of them fail, and that shows us and shows our stakeholders whether how well the code is aligned to the specification and how everyone's expecting it to work. Again, it might sound futuristic if this isn't something you used before, but TIR 45, this great guidance document established back in 2012, that you can use these techniques as part of any kind of regulatory or compliance documentation bundle. So BDD has this tech underlying it, but it's also a collaboration model. So it spells out how we sit down together, how we bring together what we call the three amigos, the business, the devs, the testers, to agree what these acceptance tests are, and then how we go through a sprint cycle and prove that we've generated these. So this is BDD, if you didn't know what it was before. So what I decided to do was to see how much this would help us using our AI coding tools. So I decided to do an experiment. So I went back to our ibuprofen dosage calculator to see how much it would help. I've also tried this on a number of client projects and test projects to see how good a fit it is. And I've got some really interesting results. So let's just step through that a moment. So step one, I produced a product requirements document. In this case, I got the AI to generate it, but this might have come from stakeholders or from wherever your requirements document might come, your marketing team. In this case, I've got 3 user needs and 20 requirements. I then fed that requirements document into Claude Code, and I said, please generate our BDD specification files. So these are the given when thens. You can see over here, maybe it's in small print, we've got given when thens that have come from our PRD. They link back to the PRD, so there's references to requirement numbers to give us traceability. In this case, I use Claude Code to generate it. We might do our 3 amigos like we do normally with BDD, or some combination of the two. But we now have specifications that link back to the PRD. Then the next step is we look to automate those specifications. Now, this is often a drag on the dev team when they're doing BDD. At Bluefruit, we do BDD on all of our projects, but we don't always automate, and part of that is because there's quite a burden to automate all those tests. But when you lean into these coding tools like Claude Code, it can generate all of these really quickly for you, saving loads of time. In this case, we can see that it generated 55 scenarios, so those are 55 tests, and 52 of them were passing. The normal BDD workflow is we'd create these tests before we write the code, and then we write code to pass those. In this case, and if you've got legacy code or soup or anything like that, you can equally generate the test afterwards, which is what happened here. So I wrote these tests around that vibe coded example that I gave. And then I ran them against the target code. And that outputs, the toolchain outputs living documentation. So this is documentation that's automatically generated based on artifacts that we're producing anyway. So with very little effort, we've now got specifications and test protocols with test results against those, which are contemporary with the code that we're producing. So we store these in our Git repository alongside our code. And so for any given release, we know what the specification was and how the code was performing against that. In this case, we can see we actually had some failures. So those of you who didn't give the vibe coding a high trust score, that was kind of well-founded because we found some bugs here. Now these bugs may be problems with the software, or they may be problems with the spec, but basically it's where the software doesn't align with what the spec says. I could also get the AI to generate some of our other living documentation for us. So I got it to generate a coverage report because we put traceability into those specifications. So not only have we got passes and fails against these specifications/tests, we've also got our test report against the PRD giving us clear passes and fails with live documentation, with traceability as well. So let's just take stock of where we're at. Having applied BDD to our agentic AI, how are our cons looking? Well, lack of transparency, that's looking much better now. We've got clear living documentation, guaranteed to be up to date, describing what our software is doing. Traceability, we had no traceability before. Now we've got links through from our PRD to our specs, to our tests, to our code. So we know what all the software is doing and we know which specs are being achieved. Unsafe assumptions, this is one I was worried about most. We've now got these guardrails. So where the AI is making decisions on its own, making assumptions without checking in, we can now see where that's not aligned anymore with what the stakeholders are expecting. In this case, it wasn't medically compliant. We're maybe not totally there yet, but we've got a framework of verification which is aligned with the standards. And if we start layering in some of our other agile practices like TDD and also code reviewing and all these other parts that we need under the standards, we've made a good start against our compliance. So where does that leave us with the question about would you trust your life with it? Time for another poll, if you could get your phones out again. What do you think? Have we made any progress? I think our average was about 3 before, so we've definitely kind of crept up to sort of 4.5, 5, that kind of space. So I think it's important that, as I think I said at the start, that these AI tools are really powerful. I think there's a lot of appetite to try and use them and benefit from these tools. I don't think there's a silver bullet to make it completely safe, but it reminds me a lot of when cloud computing came out. There was a lot of skepticism that it was going to be the way that things were going to work, but over time people found ways of mitigating the risks associated with cloud computing. And so I think there's something similar going on here, but I think the sort of view here on the audience tonight, it mirrored how I felt about the solution here, is that it was a kind of a good step forward, a good tool to add to the toolkit, but doesn't solve all of our problems. So I gave some thought to why I wasn't happy, and one of the main reasons I wasn't happy was because we'd used Claude Code to generate the code and the test. There was a sort of lack of independence around this, and when you actually look at the tests, there's a risk of the AI doing its hallucinations or trying very hard to please you and give you the results that it thinks you want to see. And so I was a bit kind of nervous about these tests, and BDD kind of, that workflow is quite dependent on you being able to trust those tests. So the conclusion I drew is I didn't actually trust these tests, which is maybe a kind of plot twist in where we were going with BDD is not the silver bullet. Again, I went back to the toolkit that we have with junior devs and thinking about how do we address this. There's all kinds of things that we can do to help. We can have reviews around the code, the tests. We can manually run some of the tests to check we're getting the same sort of results. But there was a tool that I was really keen to try out on this, which is something called mutation testing. And this is an interesting tool that I've not used a lot in the past, but I did some experiments with this workflow. Now, if you haven't come across mutation testing before, it's a really interesting technique. The goal of mutation testing is to test the effectiveness of tests. And the way that it works is that it goes into your code base and it effectively injects bugs into your code base, all the way through your code base. at every point it can find. So every branch, every if statement, every loop, it goes through and injects a mutation, a mutant. And it then runs that code through your tests to see how many of those bugs will your tests catch. And then that gives you a metric of how effective your tests are. And this is a really effective way of measuring the effectiveness of your tests. So compared with, say, another technique is code coverage, and you can see how much of your code your test is exercising, but it doesn't actually tell you how effective those tests are. So I found a mutation testing tool suitable for the framework we were using and ran those against the code back in an ibuprofen dosage calculator. And I was quite surprised at the result. So it generated 141 mutants to test our test framework, and the tests that we generated only caught about 30% of the bugs, the mutants that were injected. So that's not very effective at all, especially given it was quite a small, simple code base. So we were kind of right to not feel much trust for these tests that had been automatically generated. So I showed Claude Code the result. I gave Claude Code the tool. I was using something called Striker, and I got it to use its kind of feedback loop to iterate. If you're not familiar with Claude Code, a big difference with Claude Code compared with just using something like Claude is it's an agent. So you can give it a task and a to-do list, and it will work through that. It will use tools to help it achieve those goals. So I could give it Striker, the mutation testing tool, and say, work through this, diagnose why these tests aren't catching these mutants, and address it. And it went through that. It took a while, and I needed to guide it as well. Just to give you a sense of the timelines here, the original vibe coding took about 3 minutes. To add BDD to all of that and generate all that documentation took about another 20 to 30 minutes. So, 10 times longer, but still way short of the 3 days or something it would have taken otherwise. The mutation testing and going through this and working through and diagnosing that added about another 90 minutes. So again, we've significantly slowed down the AI coding, but it's still a lot faster. And we're starting to trust a bit more what's coming out of it. And we got to the stage where we had about 80% of the bugs being caught, which is a pretty good mutation score. The ones that it was missing were things like literal strings, and which can vary and were understandable. What was particularly fascinating what were the issues? Why hadn't it worked? And there were problems right through the V model. It was really fascinating. So there were gaps in the specifications. I think we've probably all seen that. The specifications weren't as perfect as we thought they were. So for example, there was an age range that wasn't covered well in the PRD. The AI hadn't complained about that. It had just guessed what we wanted to happen for babies under 6 months. Now, I'm not comfortable with that. The AI was comfortable with that. It was only when we got to the mutation testing that it highlighted the fact that there were these gaps. It identified gaps in the specs and the tests, and it even identified problems in the code. So for example, it found some dead code, and it was injecting bugs into this dead code, which the tests could never catch. Mutation testing, I learned a lot from this exercise about mutation testing, and actually even away from using AI on a team, it's certainly made me think about using mutation testing more in our normal workflows. So one last time, just coming back to the cons, all of these ones were kind of tackled by BDD, and mutation testing now started giving us some credibility on the tests, which also boosted the value of the BDD workflow as well, because the BDD workflow is leaning into these tests, and but if we weren't sure that we believed them, then it didn't have so much value. So one last poll. how do we feel now if we add BDD and mutation testing into our workflow? Are we feeling any more confident about using AI for safe tools? I think before we had an average, initially we had an average of about 2 or 3, that bumped up to sort of 4 or 5, and looks like we've still got quite a spread. If I'm honest, I feel the same way, but I think what this kind of shows me is that as we start bringing in these tools that we use for junior developers, it brings some hope that we can actually make some good use of these AI coding tools. And in this case, it is in a kind of regulated space. If you're not in a regulated space, then maybe it opens the doors even more to having value there. So just to recap, we've got our AI coding tools. If we add in our standards, then that helps gives us a framework and make sure that we're doing all the right things we need to be doing, code reviewing, and testing, and having good specs and traceability. BDD adds in this transparency, so we actually know what it's doing, and we know for any given release what the current spec is and how well aligned the code is to that spec. And then mutation testing starts building our confidence and robustness that whole workflow is kind of hanging together. Just a little reminder about Bluefruit. Me and Alex are around here today. If you're interested in anything that you've seen here, then we can help, whether it's with training, workshops, coaching. We can help get you set up with automated testing, and we also provide software development teams, V&V teams, that kind of thing. Any questions? I forgot to say at the beginning that the app allows you to type questions in there, but we can also take questions with a microphone. I will just have a quick look and see whether anyone entered any questions, noticed that you could enter questions in the app. Otherwise, if we can just, any questions? Yeah, first one up there.
Thanks for the presentation. Did you try to benchmark this against your human developers and see how they compare, particularly for the mutation testing, to see if they did any better than the AI did?
No, I didn't, but I think it would be a great thing to do. I'd need to decide on whether I told them in advance or not, or maybe just look at a previous project. We can run mutation testing against any sort of legacy project or current project. And it can be used for the kind of acceptance level testing that BDD does, but also for unit testing as well. I think it'd be really fascinating to see. I would expect for one of our teams who was following a kind of full TDD test first type workflow, I'd expect to see those results quite high. I've seen a paper actually which compared test first with test last, and they used mutation testing to measure the effectiveness of those two techniques for unit testing. And that paper showed it was something like when people were doing test last, the average was about 60% mutation score. And when they were doing test first, it was mid-80s. The other fascinating thing from that report was the spread of the mutation testing results. So the teams using test first had a very narrow span, so they were all in the 80s. When they did the mutation scoring for test last approach, it was a very wide spread based on the experience of the developer. So developers with very little experience were actually getting more like 20 or 30% mutation scores. So that's not from our teams, but that's some kind of general results I've seen from mutation scoring.
Follow up. Would you expect to have to keep that mutation checker in the loop going forward? Because the thing that I've noticed is even if you get the test set up really well in the beginning, the AI figures out how to make them pass. If you just say, make these tests pass in the end, and it'll try and try and try. And then if it kind of can't figure it out, it'll just like change something in the test and turn it green.
Yeah, there's definitely, I've seen a sort of propensity to kind of cheat. And so, yeah, I would include mutation testing in the pipeline. That it's quite slow because I think if I understand it correctly, it basically injects one mutant and runs that against your test framework. So I don't think it could inject all 141 because it would just destroy the whole code base. And so it might be something that you just run less frequently as a kind of check rather than running like you might with your normal tests.
Have you tried mutation testing on functional languages at all?
No, I haven't. That would be pretty interesting. I can't see any reason why it wouldn't be as effective. In some ways, I'd expect it to be more useful because normal coverage reports wouldn't be so useful on a functional language, whereas mutation testing really gets to the bottom of whether your tests are actually working. But I've not tried it, so yeah, I'd love to hear. Sorry, just could we have the?
If you perfect your specification, like bugs that you had, then you can use formal verification on it.
Yeah. Yeah, no, really interesting. Thank you.
Is there a limit to the size of the PRD?
Sorry, say that again?
Your requirements document, is there a limit? Any limits?
The short answer is yes. So
What are the limits?
I'm not sure is the honest answer. It depends a bit which AI you're using. So you start getting into the territory of how big your context window is. That's one of the kind of limitations of these tools. As the new versions come out, their context windows get bigger. If you are working on a larger project, you may either need to break it down a bit more into components to help with that. Or there are some models which are better and have a bigger context window that maybe aren't as strong in other ways. So for example, Gemini.
Wait, if you break it down, how are you going to maintain consistency or validation?
Right, if you've got requirements that slice all the way through the system, then that would be a challenge. So in which case, yeah, maybe trying a model that copes with larger context windows. So Google Gemini has a vastly larger context window than some of the other models. It's maybe not quite as strong in other ways, but if you need to cope with that bigger context window, then it's got context window of, maybe someone else can know the numbers, but I think it's something like 2 million tokens or something like that. Much, much bigger than the others, which are a few 100,000. So yeah, I'll definitely start there.
Hi. What do you see as the biggest sort of detractors or challenges to adopting the approach that you had outlined?
Yeah, great question. So I think the first challenge would be getting the team on board. In my experience, there's kind of mixed feelings amongst developers around how much value these tools add. It's kind of a new skill set. So what I often see is when developers start using these tools, they might have one or two bad experiences and just reject them and say, you know, this is really flawed, it doesn't work, it went wrong this way, or it's. I encourage those developers to kind of persist and kind of develop those skills and figure out how to ask better prompts and how to keep things on track a bit more. So that's definitely one of the challenges. For us, we don't write software for ourselves, we write software for our customers, and so we have to get our customers on board with the risks associated, and whether that's to do with data retention and reassuring them around that their code base isn't going to be used for training ChatGPT and that kind of thing. But I think probably the most important one is making sure that there's a kind of net gain in terms of productivity. Actually, one of the main reasons that I've been looking at this hasn't been so much around productivity per se. It's been about how can we maybe push up the quality of the software we're doing by doing practices that we've just never had the capacity or the resources to do. So for example, automating all our BDD tests, we never quite have the capacity to achieve all of that. If we can do that, but maybe just code in the way that we normally have, then we haven't lost anything. We've got all the normal practices we've got. Yeah, I think kind of those three things really: getting the devs on board, getting customers and stakeholders on board, and ensuring that we're actually getting net gains.
I wrote this in the Q&A as well. Do you think BDD and mutation testing will be part of the default hidden layer of Cloud Code and Bolt eventually? Like, it's currently MVP, but how close are we to the final product, or it's just one shot? And say they have a checkbox that's medical grade code or something like that, and it just uses all the standards, and you just wait 10 or 20 seconds longer.
I do think it's the direction some of these tools will go. I wouldn't be surprised if maybe the mainstream tools don't go this way, but maybe the specialist tools that come out, a bit like the Bolt.new for throwing together some vibe coding for a website, that maybe there may be one or two tools who kind of go down this path. There's definitely a school of thought that that for coders, we may move away from prompting and move more towards providing specs, and not sort of playing this prompting, persuading game of trying to get the tool to do what we want, but actually having a kind of tool framework where we agree the spec and then we prove that it delivers it. But I've really not seen much around mutation testing. I've not seen many people out there using that. So I've been really fascinated at how effective it is at grounding these models, because you can talk to it, you can persuade it, you can ask it whether it thinks it's done the right thing. But what I found really refreshing about it is it gave you, it really anchored it in reality. It couldn't lie or pretend or cheat the mutation testing results. And so I really wouldn't be surprised if there's a trend towards building that into at least some of the tools.
All right, quickly. So technically, how did you connect the mutation testing? Was this some tooling that you actually connected via MCP server, or is this manually you ran it, kind of copied results into Cloud Code and iterated there?
Yeah, I literally, the place I always start is at my Claude Code prompt. I say, how about we do some mutation testing on this? And sometimes Claude Code goes, do you want me to build a tool for that? I know devs who always start there as well. And I said, no, hang on, let's do some research and see whether there's a tool we can use. And it goes out onto the web. It found this tool Striker. I said, yeah, install it, set it up, configure it for me, and give me some reports from this. So I lent into Claude Code to do all that for me.
So that it was optimizing to the tests, right? Mm-hmm. How do you know the tests were right?
So we've got tests and we've got tests for the tests, right? So we started with the PRD, which is the input. We've got the specs and the tests, which it was optimizing to, and then which it definitely weren't as effective as I imagined. And then the mutation testing, it didn't have any control over that. So mutation testing is a non-AI tool, which is purely objective. It's looking at your code base, it's finding every branch in your code base, injecting a bug there, and running those against the tests. This is that sort of point I was making about how it felt really refreshing at that point that we went from this kind of abstract AI land of how it's modeled and describing everything that's going on to here's something really concrete that I can put my hand on and say, I trust the output from this, because it's almost like getting an independent team or something to kind of verify what's going on there. I wouldn't just rely on that on its own. So certainly on a medical project, on a regular medical project, we'd be reviewing the code generated, we'd be reviewing the automated tests, we'd be reviewing the test steps that it's producing, and confirming that it does what it's meant to do. But for me, code reviewing is never 100%. It's a kind of 80% check, and so mutation testing gives us an extra tool there that's really effective. Great. If you've got any more questions, I'm around all evening. I'm happy to answer any more questions. We're going to take a 15-minute break now. You can grab another drink, grab some more food, and then we'll have a second talk at about 7:45 with Bottom Dynamics.